Hi everyone, this is going to be the video about introduction of the vector field and showing some of the vector field using the Mathematica command. So I consider this two-dimensional vector field. I just use a sine and cosine so that it shows interesting features in that vector field plot. So here, this is the vector field, where xt and yt are the x-coordinates. So I sketched it using the Mathematica, and it shows that at each point you go back to the formula I just showed and calculate this vector. So given xt, yt, that's going to be the point of application right there, and if you calculate the vector it looks like this. I'm sure I probably shrunk those vector a lot or not, but to show this nicely, the directions and where these guys are pointing and heading, it is probably shrunk a little bit, but this is the vector field sketch, and here's a point that you can see that it seems like possibly all the vectors are kind of coming toward, and that point is probably the vectors vanishing. The vector sign at that point is a zero vector, and you can find these type of vanishing vector the spot of the vectors are zero. We call it a vanishing vector. This usually happens in all the different directions and put them together, and the only way that continuously have the continuity around that point with the different directions and put them together, and the only way is that becoming the zero vector. The main motivation of considering these vectors like that is probably the physics problem, but in the modern geometry, these tools and given a point and considering different vectors and became an important tool to describe and develop the geometry, and especially the abstract geometry became an important tool, although it's motivated from a physics problem. So what we're going to consider next is we're going to take that very motivational physics problem and see what this one creates. So we're going to look at this as a force vector field. So what this indicates that we have a fixed particle doesn't change. We have a fixed kind of particle, and if I drop that particle there, the force created by this force field could be electromagnetic field or gravitational field, whatever the kind of a force field is. If I drop that particle right here, force created at that position because of this force field is this indicated arrow. So that's the interpretation in here. So it's kind of picture, the general picture. If you drop it here, there are very little force is assigned. If you drop it there, almost no force is assigned. If I drop it there, seems like there's a strong force is assigned along that point. So this is a force field, and so let's to see the demonstration. So although the Mathematica does this automatically, there's a command you can generate this type of picture automatically. I calculated using the following assumption. So you can see if I choose this point and that point, the vector field I showed before, these force vectors are changing all the time. But to find the general solution like this is difficult. So what we did is that if I drop the particle in here with this initial velocity, so if I drop the particle here and throw that particle to that direction with this this much of the velocity, I was wrong. This was the force vector and this was the velocity vector. Let me show you the vector field again. So this was a vector field at that the point. You can see the force field is pointing upward. I am back here, so this is a force field. If I throw that particle to that direction with this much of the velocity, and what's going to happen to this particle if you just let it go with this initial velocity? And this is the answer. What I did is that assume at that position the force vector is not changing. I assume this force vector is a constant, and I give like very short interval of time, like a 1/100th second. During that 1/100th second, I assume the force vector is always pointing upward. Then you can see this velocity can be pulled up this way. So the next moment after that short period of time, this velocity is going to change a little bit upward. So you calculate the position using that constant force vector, which is simple integration. I was interrupted a bit. Let me consider again. So after you arrive here, like after a short period of time, like a 1/100th second, we're going to actually get a new force vector. We assume up to that point is always this up force vector. Now you write it here. Let's get the new force vector, and then it's always changing. We just assume it's, it's an approximation. So from that point on, we're going to use a slightly different force vector, and that's going to be slightly different velocity we calculated so far. So every that time interval, 100 seconds for example, we assume force vector is constant here, and then use that, and that's a simple calculation to calculate the next position. And every time you arrive in the next position, you get the new force vector and the velocity. Then you calculate that approximate calculation and on. So if we do that, it turns out the force vector field carries this particle into this path here. So you can see the force vector happened to be in the same direction of the where it's moving. So you see the distance between these dots is a lot farther apart. So after the same time interval, it's moving faster because of the force vector. It's kind of the same direction. As we arrived here, force vector is all of a sudden change. It's kind of drag into the different position. So it go around like this. So it could be quite chaotic if there's a slight different initial condition. The behavior of this could be quite different. So let me take a look at another example. So this one is push it to the right. So this is a second example that I don't know if you can see this or not. I tossed it. It seems like I tossed it upward a little bit in a different position. It's not probably left corner, somewhere else. I tossed it to the vertical way, and then it seems like the acceleration in different direction. So it changed the direction, and then it does some confusing part here, and then behaving like this. So this is the motion of the particle created by the vector field that I shown. So let me end this video by showing this vector field again and its formula, which is this one here. Thank you.